Hello friends, in this video I'll be talking about a use case called email campaigning, and we will see the role of NoSQL and also role of Hadoop. So let's go back to the implementing the email campaigning product in conventional architecture. You have a database which is on the right side of the uh, of this uh, picture, and that will have all the data required to support your email campaigning. And then you will have one or more layers of application servers which will actually process the data, apply the rules on top of that data, and compose the emails. And then the composed email will be sent as a template to the mail server along with the data such as email recipients. And then these mail servers will actually push the emails to the clients. That is the typical architecture. And as we have seen earlier, I am reiterating. In this case, the database will have data such as email recipient, and it has to be stored in real time. And the data can be quite huge, and for every campaign, email have to be pushed to all the customers. It could be batch or it could be ad hoc. And also, you need to come up uh, with a process where you can uniquely identify all the unique customers to avoid sending multiple coupons to the same customer. So it needs to be done in batch and at regular intervals. Those are the things which you need to take care for a reliable email campaigning product. And as I have explained earlier, the challenges will be if you develop a product for a smaller client which is successfully implemented. If you want to implement it for a bigger client, then scalability issues can be significant. And also, you need to take care of standard clients versus premium clients. Your infrastructure might change depending upon the size of the client. Even the code can be significantly different between the standard smaller clients versus bigger clients, and standardization will be a challenge. And if you try to implement the same application same application in using big data ecosystem, it will look like this. You will have a number of nodes. In this picture I'm depicting only two nodes, but it can be any number of nodes depending upon the data volume. And the major difference between the previous picture and this picture is that storage and processing will be coexisting. Whereas here, if you want to create a uh, clustered database, your storage will be your storage will be connected to the database over the network, as we have seen here. So if you think about your database architecture, it will look like this. You have the storage cluster which are mounted to the database servers through network switch, and the main thing which you need to understand is the storage is completely on a different location compared to your processing units, which are database servers. Whereas in the tools that are part of big data ecosystem, your storage and processing will be coexisting. In the previous architecture, as the data will be on a different layer, your databases can be bottleneck, your app servers can be bottleneck, or even your mail servers can be bottleneck, as they are running in different verticals of your infrastructure. Whereas in this architecture, your processing can be your application logic as well as the mail server logic is coexisting with the storage. So when you actually use big data ecosystem, data will be splitted across all the nodes in the cluster, which will be locally mounted to that particular node. So the storage of node 1 is only accessible to node 1, and the storage of node 2 will be only accessible to node 2. And there are different frameworks for both real time and batch processing, where it can leverage this co-locality of data and processing, and it can speed up the performance. So that's where this can actually be, that's where this can come handy to implement applications like email campaigning, which are in operational in nature but not transactional, and they can perform very well. So let's take an example of 2 million email recipients, and let's say you have two nodes. Node 1 have 1 million recipients and node 2 has 1 million recipients, and the processing is co-located with them, and the processing will handle those 1 million recipients, and then it will push the email to the desired clients. So the processing could be application logic or mail server logic. So this is called as data locality. Your data and the data which is storage and the code which is processing are co-locating, and it can actually it can give you optimal performance for some of the use cases like email campaigning. Now if you think about it, if you have a smaller client with 2 million users and 2 million email recipients, and if two nodes are working, if you have a larger client with 100 million users, you can just add 100 nodes with minimal changes to your infrastructure or code or anything which we have described in the challenges. So all these challenges can be addressed using this architecture, and so use cases like email campaigning, which are operational in nature but not transactional, can be easily fixed or implemented with tools that are part of big data ecosystem. So when we get into the details of implementation using big data ecosystem, you will use distributed storage. Data will be automatically distributed between multiple nodes. It could be HDFS, which is Hadoop Distributed File System, or CFS, which is Cassandra File System, or GFS, Google File System, which is proprietary to Google. So typically we'll end up using HDFS or CFS. For processing, if you have to do something operational like registration of customers or storing the email recipients in the database, which is operational in nature, for that you have to use HBase or Cassandra. One of these you can use. For batch, like pushing the emails or customer validation to avoid sending coupon for the same customer using multiple emails, those kinds of validations can be done in batch, and to do that tools like MapReduce, Hive or Pig will come handy. So that is it about one of the case studies, which is email campaigning, and we will talk about next case study using LinkedIn as an example in the next video. I hope you enjoy the playlist so far, and thank you very much for listening to my videos. Have a nice one. Bye.